Okay, so again, I really like this example here. It shows about how to apply target points, target datum points to a drawing, and it shows what that means in terms of a datum reference frame here, and it also shows how to simulate those datum points. Okay, so in this example, datum A is represented by 3 points here on the drawing. Okay, and the locations of those points have these basic dimensions that define where those points are. And they're really coming from these 2 points at datum B. Okay, so if you notice, we have basic dimensions for the points on datum B to what the points are on datum A. So there's 3 datum A points. Like I said, 3 points define a plane, 3 points define a primary datum. Okay, so this primary datum, I can take the part and I can set it down on those primary datums, and it'll stabilize it in those points. Okay, so these 3 points have 3 tooling points down here with round contact areas, in which case those 3 pins pick up datum A at those 3 points. And then we will need just 2 points, B1 and B2, to define datum B, and then only 1 more point to define datum C. So this was a good example of the 3-2-1 rule, and this is a good example of how we use datum simulators, in this case tooling posts, and then this was also a good example of how these datum targets are applied to a drawing. And again, they have specific locations, and those specific locations are picked up by the tool designer who designs this simulator. Okay, so that talks about datum targets. Let's talk about datum target lines. We talked about points, let's talk about lines. Identify the location where datum target simulators are positioned. The simulator makes a line contact with the part. It's shown on the drawing as a phantom line. If we were a tool designer, let's say that again, the side of the dowel pin may be used as a datum target line simulator. Okay, so if a edge of a dowel pin contacted the part, you would have essentially a line contact between the part and the dowel pin. And then the end view of the datum line target appears as a datum target point. And then compare the next slide to the previous slide. Datum C is changed from a point. Okay, so in this particular case, what we've done is it's a lot like the previous one. Okay, in the previous one, our datum C was a point here. Okay, and it's simulated with a round-nosed tooling pin. Now, in this case here, we've changed datum C to be a line. Okay, so in the end view, it still C looks like a point target, but in this side view here, this orthographic view here, we have a line, a datum target line. And then the only change we made to our fixture or our simulator is that we replaced the pin with this pin in a different orientation to contact the part in a line contact. So that is the difference between a line and a point for datum C. Okay, datum target areas now. Okay, in this particular case, we need a target area. Okay, so on this piece, what we've got is the 2 holes, the 2 mounting holes over here. Again, they have basic dimensions locating those mounting holes. And then we have the areas shaded here. And the other end, the third point, the third area, if you will, is going to be this entire surface. So our simulator is going to have to pick up this entire surface, and it's going to have to pick up these 2 areas here at a diameter of 375. So that's how we use datum target areas. Okay. Okay, surfaces as datum features. Primary datum surface is listed in the feature control frame established for the first plane of the datum reference plane. Okay, the second and tertiary datum planes are mutually perpendicular to the primary surface. Okay, so that's kind of what we're saying here. We have the primary datum plane, we have the secondary datum plane. The primary datum plane picks up 3 points, 1, 2, 3, essentially, the high spots of that. And then the secondary datum plane just picks up these 2 points. The tertiary just really has to touch 1. And this is how it's dimensioned. Simulators for datum surfaces. Okay. Again, this is a pretty good illustration of the definitions. Okay, so in this case, in this picture here, what we have here is essentially a tool which checks, in this case, this would be the position of these 3 holes relative to their datum surfaces. And so this thing acts like a datum simulator. This datum here is pointing to this perfect surface here. So that is, a datum is the perfect entity, if you will. Whereas a datum feature surface here is the imperfect piece of the part. Okay, and then the datum simulator over here has a simulated datum plane. It has some minor surface errors in it, but it's used to simulate the datum on this part. Okay, so datum feature is the rough surface on the part. The datum is the theoretically perfect surface. And then this is a tooling component that simulates datums. Okay, here is a cylinder, and it's a feature of size, and here is how we apply the datum to it. Okay, so in this case, what we have is these holes here, 2 by diameter 625 plus or minus 1. We have another leader coming from that hole with our datum. That's one way to put a datum identifier on this hole. The other way to do it is to have a feature control frame here and then apply the datum feature to the feature control frame. Again, both of these mean the same thing. The datum feature is the hole. In this case, we have a datum aligned with a dimension. Okay, in this case, then the feature of size, the cylinder, is the datum. And then what we have here is 2 different ways of dimensioning, of applying a datum to a hole using a leader. Now, if we had a cylindrical datum that we need to simulate, that can be done fairly easy with a lathe chuck or a collet, usually sufficient for all cylindrical features, in which case we could tighten up this collet on this part, and then that picks up the center line axis, the derived median line of that datum, and then it could find that center of the part. So a lathe chuck or collet is usually used to simulate datums. Okay, here is a feature of size datum from parallel surface. Okay, in this case, our datum is this slot, this 250 slot. Again, we've done it the same way by using the datum in line with the dimension lines. Okay, so slot, this applies to slots, rails, tabs. The datum is identified as the center plane. So essentially what happens here, since we're identifying it this way, the center plane of the slot becomes the datum. And then the datum feature symbol is placed in line with the dimension or applied to an applicable feature control frame. In this case, we've put it right here. I mean, we could have put in the C triangle right down here off of this feature control frame. Okay, datum feature references in a feature control frame. A datum symbol applied to a feature has no effect until the datum has no effect if the datum is not referenced in a feature control frame. Yeah, you can identify it all day, but if you don't use that datum in a feature control frame like this, it's essentially worthless. And the order of precedence is not, you need to select this order of precedence is what I'm saying. It could mean different things if these things are selected in a different manner. So what we're going to talk about in the next movie is order of datum precedence.